Okay, so here's a lovely little task to get pupils thinking a little bit deeper about fractions of amount. You can see there's only 6 questions and they all have a 1, 4 and 20 in, but the variation comes from the fact that we're changing the position of the unknown. And it kind of forces your attention onto what is, say, the meaning of the denominator or the meaning of the numerator as this question mark changes position in the 6 questions. Now we can solve them all using a bar model to help us. So we're going to have a go at that. Some of them are much easier than others, but we'll work through the 6 problems and see how we get on. Okay then, so in the first question, this is like your bread and butter bar model if you like. We've got the total amount, we know that it's 20, and we're asked to find 1/4 of it. So we need to divide it into 4 equal parts, and we're after that one there, say. And it lends itself nicely to a bar model because you can see that the calculation we're interested in here is 20 divided by 4, which is obviously 5. So that's probably the easiest of the 6 questions, you might argue. Part B then, this time it's 1/4 of something equals 20. So this time we don't know what the total length of the bar is. We're trying to find that, but we are told that 1/4 of it is equal to 20. So again, we can divide it into 4 equal parts, and we know that 1/4 of it is equal to 20. And once you've drawn this bar model out, pupils will quickly say the calculation that gets you to the correct answer. Well, I've got 4 of these quarters, so I need to do 20 times 4 to get our answer of 80. Okay, moving on to part C then. This time we're trying to find an unknown denominator. We are told the total, which is 20. And we want to know how many parts do we need to split it into, how many equal parts do we need to split it into, such that one of these parts is worth 4. So these are equal parts, so we want to know how many of these fit along its length. So that lends itself to the calculation 20 divided by 4, which is 5 of them. So 1/5 of 20 is equal to 4. Now D, it switches round, and this time we're trying to find an unknown numerator. And we're getting towards the realms of tricky to model now with a bar model. So this time we know the total is 4, and we know we've got 20 parts. So I'm just going to draw a few of them and do ... And want to know, okay, how many of these 20 parts have a value of 1? So how many of these do we need, that meaning of the numerator here, to get a value of 1? Well, if the whole length's 4, and we want to know how many of them make up 1, hopefully you can see that lends itself to the calculation 20 divided into 4, which is 5 of these equal parts must have a value of 1. Because if 5 parts are worth 1, 10 parts would be worth 2, 15 parts would be worth 3, and the 20 parts would be worth 4. Okay, moving on to the last two then. In part E, it's 1/20 of something equals to 4. So we don't know the total. We're trying to find that. But we are told that we're splitting it into 20 equal parts. I'm not going to draw all 20 out. We know we've got 20 equal parts, and we do know that one of these parts is worth 4. So just this simple diagram here should nudge pupils into the calculation that's required. We've got 20 parts, and each part's worth 4, so we need to do 20 multiplied by 4, which is 80. 1/20 of 80 equals 4. And finally the last one then, so we've got this missing denominator problem again. We are told the total. We know that the total is 20, and we're told that 4 somethings of 20 is equal to 1. So we don't know how many parts we're splitting this 20 into, but we do know that 4 of them is worth 1. So here's the suggested bar model for this one if you was to use one. And that prompt that, okay, if 4 of them is worth 1 and the whole length is worth 20, then I'm going to need 20 of these 4 parts to make my whole. So that lends itself to the calculation that 20 times by 4, there must be 80 parts in total if I want the whole length to be 20. Another way of looking at it is that the fact that we know that 4 parts are worth 1 tells us that each individual part on its own must be 1/4. So another way of rephrasing the same question would be, how many quarters can you fit into 20? Well, every 4 quarters make a whole, and then I want 20 of them, so it's going to be 4 times 20 again. So 4/80ths of 20 is equal to 1. Okay, so there's 6 different bar models for 6 different problems. And if you're anything like me, you're probably thinking that some of the bar models were really straightforward and easy to use and apply to the problem, whereas some of the ones where you're finding, say, the numerator or the denominator particularly, the model was a little bit harder to follow. And you have to have these battles in the classroom, whether you're going to stick with the bar model or whether you're going to start moving to more abstract methods. Now, talking about abstract methods, I am just going to show you one more quick way where we can get to all these 6 solutions, and that's going to be using a ratio table. So, the nice thing about ratio tables is that the actual structure that you set out for each of these questions is exactly the same. All 6 of these problems can be solved by using a ratio table, and it's just a case of putting the 1, 4 and the 20 in the correct position. So for the first one, we're finding 1/4 of 20. So the 4 quarters is worth 20, and we need to find what 1/4 would be. And if you know how ratio tables work, you can see the relationships going left, right and up, down as well. That missing number there is obviously going to have to be a 5. On part B, again, we're looking at 1/4, but this time we're told that 1/4 is worth 20. So 1/4 is worth the 20. So you can see the 20's changed position here. And then that tells us how we're going to find this missing one here. Well, this time we're multiplying by 20, or we're timesing by 4 down here. So we're going to get 80 for that one there. Moving on to part C, we don't know the denominator this time. So it's 1 out of something of 20 is equal to 4. So one of them is worth 4. I want to know how many I'd need to get that total of 20. So how we're going to find that missing one here. On part D, this time it's the missing numerator. We know the denominator is 20. And it's of 4 is equal to 1. So how many parts is worth 1 if all 20 parts are worth 4? Part E, we've got the fraction, the whole fraction, 1/20 of something is equal to 4. So one of the parts is worth 4. How are we going to find the missing part here? And then finally on part F, we know the numerator is 4, we don't know the denominator, and it's of 20 is equal to 1. So 4 of these, whatever this is going to be, 4 out of whatever is worth 1. How many would I need to get the full 20? So you can see a ratio table is a really consistent approach to get the solutions to these 6 answers as well. It's just a case of putting the 1, 4 and 20 in the correct position, which is obviously the hard part of the problem. So hopefully you've enjoyed that. It's a really lovely task to get students thinking deeper about fractions of amounts with multiple representations, either bar models or ratio tables, or you may even go to a more abstract solve an equation approach. So as always, thoughts and comments in the thread below.